Hi everyone, we are from Group 3 and today we will be talking about linear graph, quadratic graph, cubic graph and also square root graph.
The first graph is the original graph y equals to x where there's nothing interfering with the x so it passes through the origin. The next graph is moved up by 3 units as the plus 3 is outside the bracket, causing it to move up and down instead of left and right. The next graph is similar to the previous one where the graph has moved down by 3 units. This is the reflection of the original equation y equals to x on both the y and the x-axis. It happens both horizontally and vertically and they both have the same outcome. This is the translation of the reflected graph where nothing disturbs the x, causing it to move both up and down.
Quadratic graphs. A positive quadratic graph will have a U shape while a negative quadratic graph will have a upside down U shape. Translations. When there's a square outside the bracket, the graph moves left and right. When it's a negative, it moves left, while it's a positive, it moves right. When the square is with the x, the graph will move up and down. When there's a negative, it moves up, and when there's a positive, it moves down. Reflections. When the x is negative, it will reflect the graph at x equals 0 from the original on the left, and if you change the negative 2 into a negative, it will return to the original that's shown on the left. When the negative outside the equation, as you can see, the graph will reflect and become a negative quadratic graph when y equals 0.
I would like to talk about the square root graph's transformation. The first transformation we will be looking at are the reflection. As we can see, this is the original square root graph. The equation for this graph are square root x. This graph can be reflected on the y-axis and x-axis. The reflection are determined by this negative sign. If the negative sign interferes with x, it will reflect on the y-axis. If the negative sign doesn't interfere with the x, it will reflect on the x-axis. The next transformation we will be looking at are the translation. The movement of the graphs are determined by the numbers. Since the number doesn't interfere with the x, the graph will either move up or down from its original position. This number also represents the total number of units we have to move from the original position. Since the equation is square root of x in bracket plus by 2, we move 2 units up from the original position. Meanwhile, this equation square root of x in bracket minus by 2, this means we have to move 2 units down from the original position. On the other hand, when a number interferes with the x, the graph will either move to the left or to the right. This graph moves 2 units to the left because of the equation which is square root of x plus 2. Meanwhile, this graph moves 2 units to the right. The equation for the graph is square root of x minus 2.
I will be talking about cubic function. As you can see here, a cubic function graph is n-shaped. So this is an example of translation of a cubic function graph. On the left is a default cubic equation, which is x cubed. In this example, the x cubed is changed to x plus 5 cubed. The graph has shifted to the left by 5 units because of the plus 5 in the bracket. Next, we replace the x in the default equation to x minus 5. So the equation will be x minus 5 cubed. The graph will shift to the right by 5 units after it undergoes the translation. Then we turn the equation from x cubed to x cubed plus 5. There's a plus 5 after the x cubed, and you can see the graph will shift upwards by 5 units. And if we replace the plus 5 with the minus 5, the equation will be x cubed minus 5. The graph will shift downwards by 5 units. Moving on, I will talk about the reflection of cubic function graph. On the left is a default equation, which is x cubed plus 2x. If we replace all the x with a negative x, the equation will be negative x cubed minus 2x, and the graph will be reflected on the y-axis. This is called a horizontal reflection. Then we put a negative for the whole default equation, which is negative bracket x cubed minus 2x bracket. The graph will be reflected on the x-axis, as you can see the graph on the right. This is a vertical reflection, and the outcomes of both horizontal reflection and vertical reflection of cubic function graphs look the same. As you can see, like the middle one and the one on the right, they actually look the same after it undergoes reflection. And this is the end of our presentation. Thank you.